Today we will learn how to test the claim about the population mean given raw data. We will perform this test using the graphing calculator and then on StatCrunch program. Let's read the example. Listed below are the lead concentrations in micrograms per grams measured in different traditional medicines. Use a 0.10 significant level to test the claim that the mean lead concentration for all such medicines is less than 21 micrograms per gram. Assume that the lead concentrations in traditional medicine are normally distributed. First, we check the requirements. To perform hypothesis testing for a population mean, the sample size either need to be greater than 30 or from a normally distributed population. Well, this sample size is not greater than 30, but it says that assume that the lead concentrations in traditional medicines are normally distributed. Let's identify the claim. The claim is about the population mean, so we are going to write it in symbolic form. Mu, population mean, is less than 21 micrograms per grams. Now let's identify the null hypothesis and the alternative hypothesis. Remember, null hypothesis will always have the equal sign. Mu is equal to 21 micrograms per grams. And the alternative hypothesis will be our original claim in this case. Mu is less than 21 micrograms per grams. Don't forget about units of measurements. We're testing population mean and we're using the given measurements. Our significance level alpha is equal to 0.1 or 0.10. And we are given the raw set of data. We will need to enter it in the calculator. To enter it in the calculator, go to Stat, then click Edit, and enter these data values in your calculator. If you have any other values, for example, I have some other values from another problem, I'm gonna clear the whole list. Go to L1 and then click clear, enter. This will clear up the whole list. And let's start entering the data. Once we enter the data in the calculator, then go back to Stat and Test. Scroll down to number 2, t-test, click enter, and we have two input choices. We can enter data, either enter data or enter statistics. We have data in this case, so we go to data, enter. Our null hypothesis is 21, so we're gonna choose 21. We will go from list 1. So leave L1, frequency 1. We need to choose the sign either not equal to, less, or greater. This sign will be determined by the alternative hypothesis. The alternative hypothesis has less sign. I'm already on the less. Go down. Click calculate. We rewrite the test statistic rounded to 2 decimal places. T is equal negative 3.24 and p-value is equal to 0.005 rounded to 3 decimal places. Let's look at the graph. The graph shows that our t statistic is negative 3.24 and the p-value 0.05. We are testing it against the value significance level 0.01. 0.01 is greater than 0.005. Because our p-value is less than our significance level, we reject the null hypothesis. And we can use the table wording the final conclusion to help us to formulate the final conclusion. Condition was that our original statement did not have equality. It has the less sign. Original claim does not include equality, and we reject the null hypothesis. Here's our conclusion. There is sufficient evidence to support the claim, and then we rewrite the claim. There is sufficient evidence to support the claim that the mean lead concentration for all such medicines is less than 21 micrograms per gram. Now let's look at how to perform this test using StatCrunch. We will need to enter this data in StatCrunch. So let's start entering. Once we enter the data in the StatCrunch, go to Stat, T-Stats, One Sample with data. We'll identify we want our table, bar 1, and we want to perform hypothesis test for mu. The null hypothesis is mu equals 21. Alternative hypothesis is mu less than 21. Click Compute. And here's our data. T-statistic is negative 3.24, rounded to 2 decimals, and p-value is 0.005 if we round it to 3 decimals. Therefore, we make the same conclusion, reject null hypothesis, because p-value is smaller than significance level, and conclusion will be there is sufficient evidence to support the claim that the mean lead concentration for all such medicines is less than 21 micrograms per gram.